Okay, like I said, David Waters is going to be speaking to us next. I don't have a formal introduction for him. I'm going to tell you that his title of his presentation has changed a little bit. It's now called It Takes Imagination, Lessons Learned from Studying Exceptional Longevity in Dogs. Now, he's done the Old Grey Muzzle Tour with the Rottweilers. He's gone across the country twice. Last time he went across the country, he stopped and visited our practice. We were blessed to have him there, and it was an awesome experience. We had about 85 people packing the place, and they were just absolutely enchanted by the message, and they still talk about it. It was in March, and they still talk about when he came. So he's got a really fascinating message. He's got a great opportunity for you to look to your kennel clubs and some other organizations to be participants in his next Old Grey Muzzle Tour, and I'm going to let him do the rest because it's awesome.
Okay, can everybody hear me all right? Do you want to turn down the microphone a little bit? No? Okay, all right. Well, thanks, Marty, for the introduction, and thanks to Patty Strand for the invitation to come back and be with you guys. I spoke, as some of you know, who was in Harrisburg when I was there 2 years ago, and we had a great session together, so I was excited to come back. For the last decade, I've taught a graduate level course on the biology of highly successful aging. It's called BCS 65000. It's a semester-long course, which is way too long to fit into an afternoon session. So in the hour that we're going to spend together, I wondered what I might talk to you about. And since your theme for this year's meeting is the conversation begins with you, I thought what I would do is borrow, build upon, hijack, whatever term you would like, but I would build on this theme and say the conversation of healthy aging of our pets begins with you. And I would also say here, and people, because our work in Rottweilers is designed to unlock the secrets of highly successful aging in pets and people. So, thinking about it, this theme of conversation is a good one when it comes to health, because one of the key products of conversation is unlearning. Unlearning. That means the willingness to get old words out of our heads and let new ideas come in. Unlearn the things that we think we know. I'm in agreement with the sage Mark Twain, who wrote, "Education consists mainly in what we have unlearned." Right? So, how easy is it to unlearn? Not very. Einstein said is the toughest thing to do is to unlearn. Will you unlearn today? I hope so. So, conversation is communication, and so we might ask the question, how well then are we communicating? Well, oftentimes we're in situations where we're not very careful with the words we use. We use words that are ambiguous and can have multiple meanings. We're like the nurse in the urology office that picks up the phone and says, "Urology department, can you hold?" In other instances, we're bombarded by information, what I call partial truths, that are very, very difficult to reconcile and intelligently use. Take a look at this sign, Snowmass Village, established 1967, elevation 8388, population 1449, total 11,804. Okay, so it's essentially correct, isn't it? Except the language total misleads us. But in our favor, we have brains that are amazing confusion-correcting devices. So even if we're given gibberish, we oftentimes can make sense of it. And that's why, even though almost every word on this page is misspelled, almost everybody in this room can easily read this, right? Your brain is a gap-filling machine. So, in preparing my comments then, as every good speaker should, I asked myself this: what's the most valuable thing a speaker can give you? Well, maybe information would be the correct answer, or a correct answer. I'd question, maybe if the speaker calls his information facts, you will find them more valuable. Or maybe the best thing that a speaker can do is show you your own need, that you need to know what that speaker is talking about. I'll be daring enough to suggest another most valuable thing that I can give you today, and that's disorientation. I would like to say some unexpected things to make you think differently. And before you get too whacked out about that, I really want to take you to a happier place, and that would be a state of perpetual disorientation and reorientation, right? And when you think about this, you say, this is going to be the strangest talk ever. No, this is what a creative life is. A creative life, a life of discovery, is a state of perpetual disorientation and reorientation. So if you're a discoverer, if you're a scientist, if you're a health professional, this is the domains that you're in. So now you're wondering, what will be then today's domains of disorientation? And my title tips it off, that we're going to take a look at successful aging. We're going to talk about process, and we're going to talk about imagination. And more specifically, what I'd like to do is first say some unexpected things about the biology of successful aging that we're learning from our research. Then talk about the research process. Say some unexpected things about that. Give you a glimpse of the world of research. Not the least of which asks the question, what is a scientific manuscript? And all along the way, emphasize the importance of language, because language is not only how we communicate, but it's how we think. And ultimately, get to imagination and give you an unexpected definition of imagination that'll try to link all these together. Well, wish me luck. Okay, so let's talk about successful aging, and the first thing out of the chute is that as organisms, we're not designed specifically for successful aging. We're designed to optimize development and optimize reproduction. Stated differently, domesticated populations are programmed for post-reproductive calamity. Don't let that leave this room. But this is sobering, right? And if those of you who are more visually inclined, here's a cartoon, and I call this domestication's curse, which is aging and age-related diseases. And if you start here with wild animals, animals have a development and reproductive period and then a post-reproductive period. For wild animals, most of the time, death is occurring shortly after development and reproduction because of predators, poor nutrition, and infectious disease. But in domesticated species, like our pets and ourselves, we have this artificially prolonged post-reproductive lifespan where we have this accumulation of molecular disorder. That's going to happen, and we're not designed to get rid of it. We're not designed to optimize that. In fact, there's a cool thing called the disposable soma hypothesis. Does anybody know that? You know, that's abbreviated DSH, and it's not domestic short hair, but disposable soma hypothesis. And this means that after reproduction, the body is a throwaway. That's how the body is designed and optimized. And then there's this really cool concept called antagonistic pleiotropy. Does anybody know what antagonistic pleiotropy is? If you do, you can leave early. Antagonistic pleiotropy is this idea that things that are beneficial early in life are actually detrimental late in life. So genes that will optimize your development and reproduction, come back and whack you later in life. The gene that comes to mind, does anybody know the gene ApoE4? ApoE4 is the gene that's been associated with Alzheimer's disease. If you have 2 doses of the bad allele, ApoE4, you almost have no chance of living to be 100. If you have a stroke at age 85, you don't live for a year. So how come we have ApoE4 in our genetic pool? Well, it turns out that scientists think ApoE4 protects us from parasitic diseases like malaria. That's why it's there. So now if we live long enough, now we get to see the bad part of ApoE4 manifesting itself as Alzheimer's disease, etc. It's quite complex. So when it comes to cancer and aging, pets and people are in the same boat. We wrote the paper in Scientific American back in 2006 called Cancer Clues from Pet Dogs, explaining the opportunities and the challenges of utilizing the naturally occurring cancers in pet dogs to unlock the secrets of human cancer. But now, because we're interested in cancer prevention, we thought we needed to know more about aging because that's where cancers are occurring, in old tissues. But guess what? Almost no cancer scientists are trained in the biology of aging, and no biology of aging types know anything about cancer. So they're 2 independent silos, not too much crosstalk. So we had to do something about this. There are scientists who study the oldest old people, so-called centenarians, people who live to be 100 years of age. This is Neva Morris. She's 114 years old. When I did the Old Gray Muzzle tour and I was going across Iowa to visit one of the oldest living Rottweilers in the United States, Neva Morris lived 30 minutes down the road in Iowa, and she was the oldest living woman in the United States. The subjects I study don't wear red floppy hats. Instead, we're testing a new idea that the secrets of successful aging can be found by studying the oldest old pet dogs. So, the Center for Exceptional Longevity Studies at the Murphy Foundation that I direct has established the first systematic study of the oldest living dogs in the United States, starting with Rottweilers. And now we have a database that includes information on more than 250 of these Rotties that have lived at least 13 years of age, equivalent to 100-year-old people. By the way, at any given time, we're trying to track these dogs throughout the United States, and there's only about 15 or 20 of these dogs alive in the United States. Well, that means you can't sit around in your own backyard and wait for these dogs to show up. You have to get out there and visit these dogs and study these dogs in their homes. We got that idea back in 2010. And we did what's called the Old Gray Muzzle Tour, and in 22 days I drove 4,000 miles and took 3 plane rides, and I visited 15 of these oldest living dogs in their homes so that I could study them. More recently, here in the spring, as Marty alluded to, we did an Old Gray Muzzle Tour in 2013, and this is me and Kiri. Kiri's 15, she's equivalent to a 116-year-old woman, and here we're out in the snow, terrorizing one another, I guess. But we call this type of unique approach out of the laboratory and into the living room. And really it satisfies an essential tenet of discovery, doesn't it? No substitute for first-hand observations. You can't lock yourself in the lab thinking about heart disease. You need to get out and see heart disease. Or read a book about intelligence. No, get in a classroom and see how kids learn. So, what we did on the Old Gray Muzzle Tour 2013 was really be true to ourselves and combine this dual imperative, and that is not only to discover, but to educate. So, on Old Gray Muzzle Tour 2013, I did 12 scientific stops. That's where we visited the dogs in their homes and studied them. And then 13 what we called celebration stops. And these were nights, as Marty described, that we were hosted, and we spent a night celebrating the progress and talking about the possibilities. So, some of the education that's going on, this is an article that was written at the end of the tour that is in VIN, the Veterinary Information Network, is shared with the veterinary community. Here's Kiri. And she's dressed up as a sheep with little Bo Peep there. But it goes beyond, the research goes beyond just visiting these cool dogs in their homes. And these dogs are cool, let me tell you. I'd say to people, they're like the Galapagos Islands. You go to one island and you say, wow, this is off the charts. I've never seen anything like this before. And then you go to the next island and you say, this is off the charts. I've never seen anything like this before. And each one of the dogs is so unique. But it goes beyond that. Here's a paper that we wrote a few years back. This was an invite by the National Academies of Sciences to say, will you come up with a summary of the challenges and opportunities of using pet dogs as a model to study highly successful aging? So, let's talk a little bit first about what are the goals of biogerontology research, because I think it's quite confusing. Scientists like myself in the biogerontology field have been pretty lousy at expressing the goals. It's not reversal of aging, it's not immortality, it's probably these two guys, compression of morbidity and increased health span. Do you know these words? Do you know these terms? You will. Health span means living healthier and longer, and not just tacking on more months or years of disability. And compression of morbidity is essentially the same concept. It's not just focused on how long we can live. It's to try to compress all the morbidity in the fewest number of years. Imagine yourself healthy, 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 and then you and the rest of the population falls off a cliff. That's compression of morbidity. And not just have people or our pets live longer with more disability. Okay, so I wanted to talk to you a little bit about some of the questions or some of the unexpected things that we encounter if you were going to take a course in the biology of aging. I know that we're short on time, so I will talk about a few of them. One of the things is this issue of what percentage of longevity is heritable. I think this surprises some people sometimes. The correct answer, based upon human twin studies, is 20 to 40%. So what I just told you is good news, right? Because what I just told you is lifestyle matters. So longevity is not so strongly genetically hardwired that we can blow off whatever choices, lifestyle choices we want to make. We call this, there's plasticity to longevity. That's the good news. So health professionals like myself, think that we can step in, and if we understand the aging process, we can do something about it. How do we study aging? What are the organisms most commonly used? And here's our workhorses: yeast, worms, flies, mice in cages. And really, that's a little bit of a disconnect, isn't it? Because I said that we want to study health span, right? So how can you tell whether a worm is really having a great quality of life or a yeast is having a great quality of life? Do you check their heart? No, the worm doesn't have a heart. You know, flies, how about climbing stairs? So that's why we say our pet dogs, who are in the same boat as us in terms of aging and cancer, are great opportunities for us to measure stuff that makes a difference, right? Like the ability to climb stairs, the ability to communicate with people, heart function, and so forth. There is an intervention that has been most consistently associated with extension and longevity, and I don't know if you've heard of it before, but it's this, called CR, caloric restriction. And caloric restriction in most experimental systems is a 30 to 40% drop in calories, and it's been known since 1935. More recently, there's been data from monkeys showing this, but it's a valuable tool, but a completely impractical intervention because we're not going to cut our calories that severe. You wouldn't want your bus driver who is driving your kids to school to be on caloric restriction because he or she would have no concentration whatsoever. Women stop cycling, and so there are multiple problems. But if you look to the future, you can imagine this. caloric restriction mimetics, if we can figure out the science, the physiology of how caloric restriction can extend longevity and slow down aging, then we can create a pill. You brush your teeth at night, you pop a caloric restriction mimetic, you mimic the physiology of caloric restriction. What about oxidative stress and aging? You hear about this if you turn on the TV. You're going to hear the commercials for antioxidant vitamin supplements that you should be taking. What is the evidence? The best evidence comes from more than 10 years ago, and this is a study in worms, where they take worms and they allow the worms to roll around in a chemical that is an antioxidant defense mechanism. It mimics the SOD in our bodies. And what happens? Those worms live longer. A study was done then, what I call the home run study, to try to say, okay, that's worms. What about mammals? And here's the study in mice where they genetically upregulate the antioxidant defenses. And what happens? The mice don't live longer. In fact, they live a little shorter if we crank up their antioxidant defenses. And then there's this study. Who knows this study from PNAS, the Proceedings of the National Academy of Sciences? This is by Ristow. This is a really interesting study, right? This is a study in people, and he has the people exercise, and in response to exercise, they have beneficial effects on blood sugar. But now, if he has the same people exercise and gives them high doses of antioxidant supplements, the supplements block the beneficial effects of exercise. Holy crap. Two good things cancel one another. Two things that we thought were good. Well, that just shows what? How little we know. And, in fact, this word K-N-O-W, talk about language, we don't use it anymore in our group. I would encourage you not to use it because you don't need to. You can use words like believe or understand, and they work just fine because we know almost nothing. I write a health news column, and I wrote about Ristow's work, and I entitled it When 1 + 1 = 0, right? So 1 + 1, two good things cancel out. It's frustrating how little we know. Maybe the whole key to successful aging is all about resilience. And that's what we should be studying. Well, there's good reason to study it, right? Because the functional state of any organism reflects its attempt to adapt to environmental challenges. And if you want to read a good book, a difficult book, but a good book, this is a book from the 1930s by a neurologist named Kurt Goldstein. He did a lot of work on patients who were injured, had brain injuries from World War I. And he has a lot of interesting things to say, one of which is I'll show you here. Listen to what Goldstein says. We've become so accustomed to regard symptoms as direct expression of the damage that we tend to assume that corresponding to some given damage, definite symptoms must inevitably appear. We forget that normal as well as abnormal reactions or symptoms are only expressions of the organism's attempt to deal with certain demands of the environment. So, isn't that amazing? What Goldstein is saying 80 years ago is, when you see a patient, when you look in the mirror, you're the result of insults and response to those insults. Your body, your pet, is trying to make attempted solutions to challenges. And that's what we see as clinical signs, as veterinarians. So, in the veterinary world, we have what's called a problem-oriented medical record. So, according to Goldstein, we should get rid of that and say attempted solution-oriented medical record. Headache, constipation, those are all attempted solutions by the organism. Do we think that way? No. We see those symptoms as the insult and not really the response to the insult. So if we refine, based upon that, we refine our research question, perhaps this is what we should be shooting after. What are the physiologic factors that favor an organism's high capacity for finding successful solutions in response to demands or illness? That's what resilience is. And that's probably what goes away with aging. And when we see exceptionally long-lived dogs or highly successfully aging people, it's the people who have figured out a way, the organism has figured out a way to find successful solutions. So now, from all my experience in teaching the biology of aging, I can funnel it all down to two fundamental concepts that are underutilized. And it's the concepts of life course perspective and whole organism thinking. And let me just expand on that for 1 second and say, life course perspective is this idea that adult health outcomes are influenced by early life events. Sociologists know this, right? Sociologists get this completely. Biologists, a little slower. Veterinarians, a little slower, right? So as veterinarians, we have geriatrics programs. We wait until we have older dogs and cats, and then we try to do something to benefit them, instead of taking this life course perspective and saying, we need to make superior early choices, because that sets up either successful or less successful trajectories. It's not waiting until old age happens. Whole organism thinking, that's a good one, right? Because we're in an age of specialization. And if you think whole organism, you start thinking about trade-offs. You don't see any choices or any interventions as good or bad. You see them all as good and bad. So a question like, is vitamin E good for you, is a nonsensical question. You're no longer satisfied with that because you're saying, yes, vitamin E should do some good things. I expect that. But now I expect you to show me the bad things as well. So those would be the concepts that would be important. I'll show you the idea about taking a life course perspective. As I mentioned, early life events influence adult health outcome. Here's my son, and he's sharing his environment with the dog. And what is this doing in terms of his health trajectory? I don't know, is this a commercial for Ruffles? But you have to wonder what's going on. It is reduced fat. It was pointed out that it's reduced fat Ruffles. Okay, so Vince Felitti is the investigator that's tapped into the Kaiser Permanente huge database and people, and has done a lot of work on what he calls the ACE study. And the ACE study stands for Adverse Childhood Experiences. And what they can do is they know the health trajectories of these people and how long they lived, and then they compare that to the number of adverse childhood events. Violence in the home, a parent incarcerated, a parent that dies, and so forth. And what they can show is as adverse childhood events increase, you get a whole host of problems. Increased risk for diabetes, shorter lifespan. It's really quite incredible. Here's their work on adverse childhood experiences are associated with increased risk for lung cancer. Wow. So in other words, early life events we're talking about in the first 15 years of life in people influence lung cancer risk. Now, anybody have a good idea how that might happen? Well, people who have more adverse childhood events turn to smoking as a coping mechanism. So there's no doubt about it. If you have more adverse childhood events, you're more likely to be a smoker. But the really important part of this study was that after you control for smoking, the association between adverse childhood events and lung cancer risk holds, independent of smoking. So what is that all about? Some sort of stress, maybe. Stress, perhaps. Again, in the magazine article that I wrote, I said successful aging starts early. Maybe you think that means 40s or 50s or whatever. No, I'm talking about 15 years of age and these adverse childhood events. So one of the words that you probably hear when you think about aging research or hear about aging research is this idea of biomarkers. Everybody's trying to find a biomarker. This is a blood test or some other test. It has to be non-invasive. I could steal your urine or your hair or blood, but not a piece of your brain or a piece of your prostate. That would be too invasive. And then from that, I would generate information that would say, these people here are aging at a highly successful rate, and these people over here at a less successful rate. Well, it's been largely unsuccessful, very frustrating. We don't have really good biomarkers of aging. And so now you might ask this question: could paying closer attention to life course perspective fit some of the pieces of the biomarker puzzle? Take a look at this. It's what I call the flip-flop of physiology during the life course. And it goes something like this. Here's an investigator, Kivipelto, in Scandinavia. And she studies people and tries to understand the factors at age 50 that predict subsequent Alzheimer's disease. Okay? And what does she find? High serum cholesterol is one of the strongest risk factors at 50 years of age that will predict Alzheimer's disease in the next 20 years. Okay? Man, maybe we have an effective biomarker. But other people have shown that in people who are 70 years old, high cholesterol appears to be protective. So now it flip-flopped over the life course. Remember I said to you, once you start thinking this way, life course perspective and whole organism thinking, you're not going to see very many things as good or bad, effective or ineffective. It's both. It's trade-offs. And we have to understand that better. Another quick example is, with increasing age, fatness loses its sting as a harbinger of death. So obesity is, no doubt about it, really significant risk factor for early mortality when you're in your 30s, 40s, 50s. But you reach a time when some investigators have shown that in advanced age, favorable survival may be more closely linked to more fat than linkage to muscle mass. What's this all about? How do we explain this? Maybe it's because when grandma falls at the mailbox, she bounces and rolls rather than fractures. That's a possibility. How about another possibility? When grandma fractures her leg at the mailbox and goes in the hospital and develops a nosocomial infection, she's got pneumonia. If she's a little fatter, she has more energy stores, so she survives the pneumonia. So maybe that makes sense, but do you see how life course perspective might put us on the right track? Okay, so let's look a little bit at our work from the Rottweilers and see if I can summarize some of it. One issue for sure is this idea of cancer resistance as an important part of highly successful aging. Rottweilers are a highly cancer-prone breed. If Rottweilers die with usual longevity, which is around 8 or 9 years of age, cancer is the cause of death about 80% of the time. 80% of the time. But these dogs that live to be 13 years of age with exceptional longevity, cancer is the cause of death in only about 25% of them. So they're cancer resistant. Now, be careful with language, right? What does cancer resistance mean? Resistance to cancer mortality, because what happens at autopsy? When we do autopsies on these dogs, and we've done now more than 60 dogs, can you imagine that? 60 autopsies on the oldest living dogs in the United States. Greater than 95% have cancer at autopsy. Sometimes 2, 3, 4 independent cancers, right? So what have they figured out? The oldest old Rotties have figured out what every cancer scientist wants to figure out. How do you transform lethal cancer into a non-lethal nuisance? We're air-breathing mammals that live a long time. Cancer is part of us. But we can work on limiting cancer mortality. And that's what I think these Rottweilers can show us how to do. In the spring, I gave a TED Talk. You can go online and find this TED Talk. It's called "The Oldest Dogs as Our Greatest Teachers." Get the words out of your eyes. And I talk about the cancer resistance story. And I also talk about a second story, and that is the data that we're generating on stress and highly successful aging. So watch the TED Talk so I can talk about something else here. The third thing that we've spent, that's popped out from the data is, we've been the first, I think, to convincingly show that in the dogs, there is a sex difference in longevity. This is my most controversial slide, that we know that in women and in people that live to be 100, women are 4 times more likely to reach 100 years of age than men. There's a strong female longevity advantage. What about supercentenarians? These are people who live to be 110 years old. Female advantage is wild. It's 20 to 1. Can you imagine? 20 to 1. So what are these girls doing that we need to find out about? Well, we don't know. Look at what Stephen Austad, a biogerontologist, has recently said. Human sex differences in longevity may be the single most robust aspect of human biology that scientists do not understand even in the broadest terms. So now, remember our resilient story? Remember our resilient story? The question becomes, would healthy longevity and resilience be influenced by endocrine organs? Right? Does that make sense to you? Because endocrine organs, by definition, are organs that produce stuff that has system-wide effects. So maybe that's their secret, the females. Well, we made a discovery right away when we got in this work, in this business, because in pet dogs, no previous studies had evaluated the association between the number of years of lifetime overexposure and longevity. I'm going to say that one more time. No previous studies had looked at the number of years of overexposure and how that relates to longevity. Right? So I don't think that we surmise that our profession hadn't really looked at this association very carefully. The results that popped out, we published in the journal Aging Cell. I don't think you read this journal, but let me just say that there are 57 peer-reviewed journals, scientific journals on biogerontology and age-related disease. This is the top impact journal of all 57, and here is the paper that we published now back in 2009, and it's exploring mechanisms of sex differences in longevity, lifetime overexposure, and exceptional longevity in dogs. And I can summarize the data for you, and this is when we compare the longevity and factors in the exceptional long-lived Rottweilers to a group of Rottweilers, again, nationwide, that had usual longevity. We found a 2 to 1 female to male survival advantage. So we documented this female survival advantage that is known in the human population. But the interesting part is, if you lose ovaries in the first 4 years, you erase the longevity advantage. Taking away endocrine organs early in the life of a mammal decreases that female's likelihood of reaching exceptional longevity. And this ovary effect is independent of cause of death. So we looked at dogs that died of cancer versus not cancer, and that the ovary effect holds. Independent of familial longevity. In other words, when we account, exceptional longevity clusters in people, right? If your brother lives to be 100, you're 15 times more likely to reach 100 than the average person. There's familial clustering. And when we control for that, again, the ovary association with increased longevity holds, and also independent of reproductive effort. And that's the most recent paper we published in the spring. And maybe we can talk about that more at the discussion. Within a few months of us publishing those data, there was this paper that came out in Obstetrics and Gynecology. This is William Parker's study of 29,000 women who underwent hysterectomy. About half of them kept their ovaries, about half of the women lost their ovaries. And what did Parker find? That if you don't want to lose your ovaries in the first 50 years. If you're a woman, because it increases your overall mortality, your cardiovascular mortality, even increases your risk for lung cancer. And also within a few months, a mouse study, which was a transplantation study, where they take old female mice, they transplant into those old mice young mouse ovaries, and they push longevity by 15%. So here, within 6 months' time, we had this information coming from 3 independent investigators, 3 different species, and this compelling convergence that suggested that ovaries are part of a system that promotes longevity. Now the question is, can we reconceptualize ovaries, or are we stuck in our preconceived notions that ovaries are reproductive units? And that's what spaying is all about. But they're endocrine organs, and if you ask me, one of our jobs is really to get this point across. Because if we can teach, for example, veterinary students that ovaries are endocrine organs, then maybe ovaries will join the ranks of the rest of these organs, like the adrenal glands, the thyroid glands, the pancreas, that we retain. We don't remove. How often do we go up to a client and say, I'd like to rip your dog's thyroid glands out? I think it would be beneficial. I mean, you guys are snickering. That's elective endocrinological disruption. That's what the removal of endocrine organs is. So that's our challenge. So that's successful aging. Now let's talk about process. And by that I mean the process of research, and try to give you some sort of glimpse and maybe say some unexpected things. I think you really have to think about research as a process and not a thing. I think too often we think about it as a thing. And I tell my students, you should never talk about biogerontology research. Always use ing words, because ing words give you the sense of process and notify you process. So really, when we're doing aging research, we're doing aging researching. And in fact, maybe it would be better to hyphenate the word that way, that we're searching and researching. And then you might say, okay, I buy into that. I like the hyphen. What are the keys to successful researching? Well, when we attack a research question, here's my idea. We should do what anthropologists do and approach our issue with anthropological strangeness. That's a great term, isn't it? Right? When the anthropologist studies a new tribe, the anthropologist doesn't go in and make assumptions. Oh, see that guy over there with the funny furry hat? His head must be cold. No, he has to ask around, because it turns out that's the guy who can predict the future. It has nothing to do with his head being cold. So the anthropologist approaches his domain with this anthropological strangeness and doesn't count on anything to be really true. So in a way, really, scientists should maybe listen to poets like Ammons. Listen to this. Maybe scientists should think about this. Don't establish the boundaries first, the squares, triangles, boxes of preconceived possibility, and then pour life into them, trimming off leftover edges and ending potential. And I think that's what we do a lot of times in science, right? We have a hypothesis, we love it to death, and then we go out and try to confirm our hypothesis instead of really being courageously open-minded. Okay, well, when you start thinking in terms of process philosophy, your whole world changes and you start thinking differently. You even look at cancer differently, because then you say, cancer's a process, not a thing. Right? It's a process, not a thing. And wow, that opens us up into this really cool thing that there's this process called cancering, and it's happening in you and I and our pets all the time. So is the goal to eradicate all the cancer cells, or is the goal to restore equilibrium between the cancering process and the healthy body, right? And that opens up a lot of opportunities and a different way of thinking. And again, if you embrace process philosophy, then you say, you are a process, not a thing. In fact, sometimes I say, go home and say that you had this really cool talk by this guy named David J. Watersing. So that's when some people leave. But that's all about your unfinishedness. And I think we should celebrate our unfinishedness instead of being freaked out by it. And some people call this, we need to be lifelong learners, but I like to think of it as we're unfinished processes. Okay, so as far as process, this is a process. Somebody's clapping because they know they have a high degree of unfinishedness. Okay, so when we talk about the process of science, then we might say, how do we benchmark progress in science? Is it the facts that we generate? I would agree with the astrophysicist Sir Arthur Eddington, who said this: it's not that way at all. Progress is marked not so much by the problems we're able to solve as by the questions we're enabled to ask. We benchmark progress in science if we can ask a new set of better questions. So really, the process of research is all about the quality of our questions, because that's how we benchmark progress. Now, I thought, if you would like to, let's look at a couple questions. Want to look at a couple questions? And the first question is this: Can we design a wellness program to promote healthy longevity? Wouldn't that be an important imperative, an important goal? And to do this, we'll do a thought experiment, okay? Ready to do a thought experiment with me? Okay, imagine an investigator who seeks to answer this question. Evaluate whether the goal of eliminating the incidence of a particular disease can serve as a core principle of a wellness program designed to promote healthy longevity. Got it? So the investigator has a particular disease in mind and is asking the question, if we can significantly drop the incidence of that one particular disease, then that can be our core principle of a healthy wellness program. Okay, let's call the disease X. Okay? And we'll say it has late onset variable mortality. So I'll say that 20 to 60% of the subjects that get disease X will die of disease X. Okay, it has variable mortality. Okay, so what does the investigator do? Chooses a study population and would probably do this: an analysis of age-specific life expectancy. Let me explain this to you. So what the investigator would probably do is take the study population of all different ages, let's say 25-year-olds, 35-year-olds, and 50-year-olds, and then ask the question, is the life expectancy of a 25-year-old person that's been diagnosed with disease X, or in the future will be diagnosed with disease X, is the life expectancy of these people cut short? And then you do it for 35-year-olds and see if disease X cuts short the life expectancy at any place over the life course. And so the investigator's done this, and the results are in. And the analysis shows that at no age during the life course does the current or future diagnosis of disease X cut short life expectancy. That's what the result was. So what would be then the logical conclusion? The logical conclusion would be preventing the incidence of disease X cannot be the core concern for establishing a longevity promotion strategy. Instead, reducing risk for other diseases, perhaps diseases that are earlier onset or more highly lethal, or slowing the rate of aging should be the components of the strategy. Right? Do you follow that thought experiment? We're all on the same page. Okay, that was a thought experiment, and here's our most recent unpublished data. And if disease X is mammary gland cancer in Rottweilers, at no age during the life course does lowering the incidence of mammary gland cancer cut short longevity. Same thing for pyometra. right? Those are the two, if we're going to leave dogs intact a little bit longer to get the beneficial effects of ovaries on overall healthy longevity, remember, it's going to be good and bad. And the downside is you're no longer prohibiting the development of mammary cancer or pyometra. But now, in using whole organism thinking, we need to ask, yeah, but remember, we're going to balance the good and the bad here. There are two diseases in our analysis that cut short longevity, and that's bone sarcoma and lymphoma. You don't want those if you're a Rottweiler, because they cut short your life expectancy. But mammary gland cancer doesn't. So, did Dr. Waters just say that all those things that we memorized in vet school, those percentages from Schneider and Dorn 40 years ago about if we spay at this time, we drop the percentage of mammary cancer by X, and if we by this heat, no. I'm all in with Schneider and Dorn. But Schneider and Dorn is talking about the effect of the timing of spaying on the incidence of one disease, not even the mortality of one disease. I believe Schneider and Dorn's data. And now, in our thought experiment, we went way beyond, didn't we? We did whole organism thinking, and we looked at the impact of diagnosing that particular disease and its impact on overall life expectancy. So good job on your thought experiment there. So, how do you react to new research? There's two cool things. We don't have time to do this, but if you know Daniel Kahneman, who won a Nobel Prize at Princeton, in his book Thinking Fast, Thinking Slow, this is a really, really cool book that tells you how does a fast brain deal with a really, really tough question. Maybe we can talk about a discussion, but I want to just spend a little bit of time on this. What really is a scientific manuscript, right? Because I think from you on the outside of research, looking to research, you say, this is the gold currency, right? This is the highest valued currency, peer-reviewed scientific manuscripts. Well, there was a guy named I.A. Richards back in the 1930s. He was a literary critic. And he once said that, you know, when you see people who seem to be so sure of themselves, and they're usually speaking the loudest, I'm not sure what they really know. Really what they're talking about is a view formed under special circumstances. And when I read that, I thought, I think Richards is onto something. See our paper that we published in Aging Cell? We could have called it this. Right? And that would be an accurate title, a view formed under special circumstances. Take a look at this convoluted title. This is some work that we did on the trace mineral selenium and prostate cancer risk. Wow, very detailed, very particular, very informative. It's a view formed under special circumstances. Here's Ristow's paper that I showed you on 1 + 1 = 0. A view formed under special circumstances. Of course it is, because Ristow chose the subjects he studied. He chose the dose of vitamin C and vitamin E. He chose the intensity of the exercise. So every scientific manuscript is just this. It's a view formed under special circumstances. That's what it is. Picasso said this: art is a lie that lets us recognize the truth. I'm bastardizing Picasso and saying my scientific manuscript is a lie that lets us recognize the truth. Right? It's not truth with a capital T. I didn't do the God's view experiment with all the variables and all the controls. It's a view formed under special circumstances. And the bottom line is, no scientist, no health professional, no highly involved person in a field should believe that your manuscript is the truth. Remember, it's an approximation. It's asking a new set of questions. It's asking a new set of questions. It's not really the truth. I don't know, was that depressing? Okay, so So now you have this inside look at the research process, and now maybe you've never thought about this, and maybe we should, and that is, what are the motives for doing research? And Wayne Booth, a faculty member at University of Chicago, who is an English teacher actually, wrote it this way: ultimately, the motives for doing research are rhetorical, an attempt to better understand a problem, then express clearly that progress to those without such experience who might believe differently. Do you ever think about this? That as researchers, our responsibility is to discover and to educate. So we have to try to clearly explain what our research is showing, or what we think it's showing. And that's my segue into the importance of language. And this coming semester, oh sorry, wait a minute, I could do that. That would really do a nice job. This coming semester, I'm teaching a writing course actually, and the theme is this. I'm going to try to tell those kids that writing and thinking go hand in hand. When you make the decision to write better, you're choosing the kind of world you want to live in. You're choosing how precise you're going to be with language and the types of arguments that you'll accept as reasonable and those that just don't cut it. So this idea of clear writing is clear thinking, and what does this mean to you? You need to read what scientists write, not just what scientists come and tell you at a meeting. You need to read what scientists write. That's what I would challenge you to do. So in a way, I'm really going beyond physical health, and I'm challenging you that we need to pay more attention to the goal of linguistic health, which maybe would be defined as seeking competence and control in using language. And this is particularly important for discoverers because language is a powerful, very valuable purveyor of the particular. We need language to tell you the particulars of what we've found. But language can be a dangerous homogenizer. And by this I mean, we rush to homogenize, and we rush to fit something in categories or in a current belief system. Oh yeah, that's how I believe, instead of really staying with the particular. I tell students, as soon as you look in the tree and you see the bird, and as soon as you name the bird, robin, you stop making any original observations on that bird. The bird's a robin. You won't make any more original observations. That's how you train your brain to make sense of the world and simplify the world. But if you're a discoverer, you got to fight through that. You've got to fight through that rush to homogenize and stick with that particular bird and make some unexpected observations. You probably think that we're, as scientists and discoverers, health professionals, we're trying to make sense of the world. I would try to encourage you to rethink that really what we're trying to do is make sense of a world of words. Because, clearly or not, this is reality. We see the world through our categories, right? So is vitamin E good or bad? I just told you, get rid of that category thinking, this either-orness. It really gets in the way of our thinking. That's why language can limit the scientific method. And as part of my TED Talk, remember the title was The Oldest Dogs as Our Greatest Teachers, but the subtitle was Get the Words Out of Your Eyes. So before you allow those words that were poured into your head, those categories and classifications that you've been taught, you need to get out there and make first-hand observations. So how about a concrete example of how language can limit the scientific method? This is a paper we published in the Journal of Theory of Genealogy. It's called Probing the Perils of Dichotomous Binning, how categorizing female dogs as spayed or intact at the time of death can misinform our assumptions about the lifelong health consequences. So the previous studies looking at spaying and longevity categorized dogs into two bins. Are you spayed or intact at the time of death? Didn't look at the number of years of overexposure. And our contention is that really can distort the real relationship between the number of years of overexposure during a lifetime and highly successful aging. And in this paper, what we do is we take our data set in the Rottweilers, number of years of overexposure. If we keep ovaries longer, we promote healthy longevity. Then what do? We do the old method, simplistic method of spayed or intact at the time of death, and the association is completely distorted. It's covered up. So we conclude in the paper, categorizing female dogs as spayed or intact at the time of death, so-called dichotomous binning, is an inadequate method of representing biologically important differences in the amount of lifetime exposure. Here would be a correlate, an analogy. Could we screw up the relationship between cigarette smoking and lung cancer in people? I know how. Walk into a nursing home and go into one of the guys' room and ask the guy a question. Do you have lung cancer? And he says, yes. And then you say, do you smoke now? And he says, no, I'm on oxygen therapy. If I lit up a cigarette, I'd blow myself up. So now you record in your notebook, lung cancer, yes, smoking, no. And you proceed down the hallway and you get lung cancer, yes, smoking now, no. But you failed to capture 30 years of smoking exposure. So you completely, in your mind, you would distort the real relationship. Let me show you a problem. Here's the paper published in JAMA. It's the seminal paper guiding veterinarians in terms of determining the optimal age of gonadectomy. Here's the reference list. It starts with 1. It ends in 183. We must know a lot about this, right? How many of these papers that evaluate the association between spaying and a health outcome, like longevity, cruciate ligament disease, pyometra, whatever, use dichotomous binning, and how many of them do number of years of overexposure? Out of the 183, there are 2 papers here that don't use dichotomous binning. So how much do we know? I don't know how much we know. I think I already told you we don't use the word. We try not to use the word. And here is the AHA blurb on a new recent paper that was published looking at 40,000 dogs in the VMDB, and conclude that spayed or neutered dogs tend to live longer than intact dogs. Sterilized dogs had an average lifespan of 9.4 years, while intact lived 7.9 years. What does that mean? What does that mean? I visited 40 females, Rotties, in their homes, the most exceptionally long-lived dogs. They're more than 13 years of age. Every single one of them are spayed. Do I come home and reach the conclusion and tell you guys a story that, see, spayed dogs live longer? No, our research suggests keeping ovaries longer means promoting healthy. We'll talk about imagination briefly and then conclude. Okay, so that takes us to imagination. Maybe you guys know this program. Who knows this program? PBS ran a program, Alan Alda hosts it. It's called The Human Spark. He goes to all of these different neuroscientists and asks what seems to be a simple question, and it's what makes us uniquely human. And I'm sitting in a hotel room and I'm watching this and I'm waiting and waiting. What separates us from all the rest of the animals? And the answer is imagination and insight. Imagination. And I thought about that for a minute. And then I said to myself, oh wow, it's how skilled you are in the non-present. Now, why would I say that? Because I'm going to give you a definition that might be a little radical for imagination, and that is, imagination is your ability to recategorize. That's what imagination is. If you can take things that previously were believed to be impossible, like Walt Disney did, and make them possible, that's recategorizing. That's using your imagination, right? Things that used to be bad for us are now good in certain circumstances. That's recategorizing. Spayed versus intact at the time of death, or number of years of overexposure during the lifetime. And so there's the link between Alan Alda, the Human Spark, and an ovary story. So, can imagination then lead to this goal of what I would call situational excellence? And that depends on this concept. Does anybody know the concept of landscape ruggedness? From information theory, this is really, really interesting. So what do people do? It depends, people behave depending upon landscape ruggedness. In other words, how complex an issue is. And as complexity increases, our inclination is to rely upon mimicking rather than exploring. So, if the topic you're interested in is not very complex at all, think of it as rolling sand dunes. You can walk along those dunes and not get in very much trouble, right? What if your topic is complex, like the biology of aging? Now you're in Bryce Canyon on the hoodoos, and if you take one step in one direction, exploring, you can find yourself in a significantly different way. So, complexity results in mimicry rather than discovery. We listen to what we were taught, what the guy in the bowling alley says, or what the veterinarian down the street does. So, is the biology of aging a highly complex topic for veterinarians? No veterinarians receive training in the biology of aging as part of their DVM curriculum. So I would think that it's a relatively complex topic. As I said to you, there's no substitute for first-hand experience, getting out and making original observations. And this is a paper that we published that talks about this whole idea of landscape ruggedness, if you're interested. Trying to get creative excellence in the research education space. All right, so you're probably tired of me. My goal today, as I told you, was to say some unexpected things. Did I do that? Did I say some unexpected things? Okay, good. I think I told you that a creative life is a perpetual state of disorientation and reorientation. There's an enormous challenge in front of us to understand the world. I like this quote by Altshuler: "The world is endless, the universe inexhaustible, and the human brain will never be threatened with unemployment." And that's if we can fine-tune our method. We can fine-tune our method. I told you we're testing a new idea, and that is that the lessons from the oldest living pet dogs can have important impact on our understanding of healthy aging and cancer resistance in both pets and people. The subject is complex. The mathematics is simple. LCP plus WOT equals SA. Life course perspective and whole organism thinking. If you've got that as part of your method, then you're thinking about successful aging in a sophisticated way. I told you research is a process, not a thing. And I told you that the world is full of unfinishedness, your own and nature's. So who's going to come and rescue us? Who's going to figure this all out? And that's why I love the quote from William James. When we're waiting for this person to come and figure this all out, meanwhile, the best way in which we can facilitate their advent is to understand how great is the darkness in which we grope, and never forget that the natural science assumptions with which we started are provisional and revisable things, right? Research as a process, we don't know much. So, how can we take action amidst the uncertainty? This is what we need. This is what you need. A non-paralytic model of non-knowing. In other words, if we don't know, it's okay because we can still take action. We're not paralyzed. We don't have the randomized clinical trial yet. By the way, there's never been a randomized clinical trial on smoking and lung cancer, but we're pretty certain, we believe strongly, that lung cancer is associated with cigarette smoke. It's just like the parachutes and jumping out of a plane. No randomized clinical trial on that either. And so I think we can get by because of this. Our actions are the products of our beliefs, not what we know, our beliefs, and they're always made under uncertainty. So here's my greatest gift to you today, perhaps. Think musical instrument. It's what I call tuba, toward understanding, belief, and action. And it just reinforces what we were talking about. You take action because you believe strongly enough, not because you know. You purchase the car because you believe strongly that's the right car for you. And then when you take that action, you get feedback. And sometimes it supports your belief. And other times you bought a lemon, so that undermines your belief. Now you go, what the heck am I supposed to believe? And what do? It forces you to go back and re-examine, how well do we understand this? How complete is my understanding? So now you try to gather a better understanding, and if your belief gets strong enough, you can act. So I think research is a process. You want to constantly be assessing the new research and asking, how strong are my beliefs? I don't know very much of anything, but if my beliefs are strong enough, I think I can take action. New ideas, bend beliefs, subtle changes in language. Subtle changes in language might be able to fit ovaries into this compartment. Organs that we want to keep around, retain rather than remove. So, wrapping up, as a discoverer, as a health professional, as a person, eventually we bump into this thorny question. Whenever we see new information, do I have good reason to doubt what so many have believed before? And when it comes to the ovary and longevity issue, I've written an essay about that. And it was recently published in a book on dogs and domestication. It's called Caught in an Act of Convenience, Disentangling Our Thinking About the Influence of Spaying on Healthy Longevity in Dogs. If you're interested in receiving a copy of this, you can pull out your phone, you can text 313131, the keyword dog aging, one word, include your email address, and we'll send you tonight that essay. I think you're really going to like the essay. Why? Because of the power of essay. Essay, by the way, comes from the Greek meaning an attempt. Isn't that precious? An attempt. Not pretending that you know everything, an attempt to make ourselves understood without fixity. And I think in the spirit of this conference, we must make every effort to avoid any assumption that the dialogue can or should ever end. Because as we keep the conversation going, this is what we do. We discover and we educate. Thank you.